In the early 2020s, the electric vehicle revolution seemed unstoppable. Tesla's market dominance, driven by Elon Musk's relentless ambition, signaled a new era in mobility. Electric was the future, and the world appeared to be on board. Legacy automakers scrambled to catch up, and the EV wave swept across global markets. But behind the scenes, a quiet giant had other plans. Toyota, the world's largest automaker, had never fully bought into the EV-only future. Known for its hybrid innovation and engineering discipline, Toyota was building something that could change everything. Not another battery-powered car, but a reinvention of the internal combustion engine itself. And what they were about to unveil could reshape the entire conversation around sustainable transportation. To understand Toyota's bold move, we need to go back nearly a century. The company's roots trace back to a small textile firm in Japan, founded by Sakichi Toyota. His invention of the automatic loom introduced jidoka, automation with a human touch, and planted the seed of a philosophy that would define Toyota for decades. His son, Kiichiro Toyota, later shifted the company's focus to automobiles and pioneered the Toyota production system, based on two principles: just-in-time manufacturing and jidoka. This system revolutionized global manufacturing. By minimizing waste and empowering every worker to improve processes, Toyota created a culture of perpetual innovation. During the 1973 oil crisis, while other automakers struggled, Toyota was prepared. Cars like the Corolla became global icons for fuel efficiency, setting Toyota apart as an agile and forward-thinking leader. In the early 2000s, Toyota again redefined the game with the Prius, the world's first mass-produced hybrid vehicle. Combining a gasoline engine with an electric motor, the Prius offered reduced emissions and set a new standard for eco-conscious driving. Toyota didn't chase trends, it set them. Meanwhile, the internal combustion engine, a pillar of modern society, was being refined year after year. Though electric cars were grabbing headlines, Toyota was quietly perfecting this century-old technology. Their legendary 2JZ engine became a favorite among tuners and racers, while innovations like VVTi and Valvematic systems pushed efficiency and performance further. In 1997, the Prius proved that combustion and electricity could work in harmony. Toyota continued to develop engines capable of running on a variety of fuels: gasoline, biodiesel, synthetic fuels, and even hydrogen. While other manufacturers phased out combustion, Toyota asked a daring question: what if we could reinvent it? As Toyota refined its hybrid systems, a challenger emerged. In 2008, Elon Musk's Tesla Motors introduced the Roadster, a fast, sleek electric car that defied stereotypes. The Model S followed in 2012, revolutionizing the perception of EVs. Tesla became a symbol of innovation and disruption. The electric dream was becoming reality. But this dream came with a cost. The lithium-ion batteries powering most EVs rely on the extraction of rare minerals like lithium, cobalt, and nickel. Mining these materials is energy-intensive and environmentally damaging. Lithium extraction in South America, for example, has caused water depletion and ecosystem disruption. In the Congo, cobalt mining has raised serious ethical and environmental concerns. Manufacturing these batteries also generates significant carbon emissions. A single EV battery can emit up to 4 tons of CO2 before the vehicle even hits the road. Recycling rates for these batteries remain abysmally low, and improper disposal threatens soil and water contamination. Meanwhile, global supply chains for battery materials are fragile and heavily concentrated in politically unstable regions. Charging infrastructure presents another challenge. In many places, it lags behind demand, leading to long wait times and consumer frustration. Moreover, if the electricity used to charge EVs comes from fossil fuels, their carbon advantage is diminished. The shift to EVs, while promising, is not without serious trade-offs. Toyota recognized these limitations and chose a different path. Rather than betting everything on EVs, the company diversified. Hybrids, hydrogen fuel cells, and improved combustion engines were all part of its strategy. In 2024, that strategy took a stunning turn. Toyota, Subaru, and Mazda jointly announced a breakthrough: a new generation of internal combustion engines, smaller and more efficient than ever, designed to run on carbon-neutral fuels. These engines, 10 to 20% smaller thanks to a reduced piston stroke, could be paired with electric motors in hybrid setups for instant torque and lower emissions. Hydrogen combustion. Unlike fuel cell EVs that convert hydrogen into electricity, Toyota's new engines combust hydrogen directly. The only byproduct? Water vapor. This innovation harnesses existing engine technology while eliminating CO2 emissions entirely. Tested in motorsports, Toyota's hydrogen engines have endured extreme conditions, accelerating development at a remarkable pace. By 2027, Toyota plans to integrate these powertrains into its mainstream lineup, offering performance, efficiency, and near-zero emissions without relying solely on batteries. Then, in late 2024, something extraordinary happened. Elon Musk, the EV evangelist himself, made a secretive visit to Toyota's headquarters in Japan. The meeting lasted 6 hours. He was shown something inside Toyota's advanced R&D facility, something that reportedly left him shaken. Upon returning, Elon's tone shifted. When asked about the visit, he simply said, "Toyota's new engine will destroy the entire EV industry." Coming from the world's most vocal electric car advocate, this was a seismic statement. Industry insiders speculate that what Elon saw was more than just a prototype. It may have been the final proof that internal combustion isn't dead, it's evolving. A hybrid engine capable of running on hydrogen, offering the power and convenience of traditional engines but with zero carbon emissions. And just like that, the narrative began to change. Scene 5. Rethinking electrification. Electric vehicle sales growth slowed. Charging networks strained under demand. The environmental costs of batteries became impossible to ignore. Consumers, governments, and automakers started rethinking the single-lane path to electrification. Toyota's cautious, calculated strategy suddenly looked brilliant. By focusing on fuel diversity, infrastructure flexibility, and real-world efficiency, Toyota positioned itself not just for survival, but for dominance in a post-EV world. The future of mobility may not be a one-size-fits-all solution, and while Elon Musk may have sparked the revolution, it's Toyota that might just finish